Welcome back to our channel. Today we will solve question number 13 of exercise 2.2. Question given is a differential equation which is e to the power y plus 1 whole square dot e minus y e power minus y dx plus e power x plus 1 whole power cube e power minus x dy is equal to 0. Now this is a differential equation because here present dy and here present dx. We will solve this equation by separable variable method and we will find out the general solution of this given differential equation. Now let's come to the solution of this given differential equation, where you will solve directly from this tip. So first we have to separate the equation on either side of the equality according to the given variable that is present in this equation. And if we analyze this given equation, so here we can see that here present two types of variable. The one is y in the power of e and the one is x which is also in the power of e. So we have to separate this term plus this term, the left term, and we'll shift this term to the right side of the equality and we'll get here e power x plus 1. On the left side we will get e power x plus 1 whole power cube e power minus x dy, and we will shift that term to the right side of the equality and we will get here e power y plus 1 whole power square e power minus y dx. Now we have to shift this term to the left side of the equality and we have to shift this term to the right side of the equality, and then we will get here 1 divided by e power y plus 1 whole square e power minus y dy, and shift e to the power x to the right side. We will get here minus 1 divided by e to the power x plus 1 whole cube e to the power minus x dx. Now I will shift the denominator to the numerator on either side of the equality and we will get e to the power y plus 1, e to the power y plus 1 whole power minus 2, and e to the power y. The power of e will become positive because here in the denominator is negative, so if we change it to the numerator, it will become positive dy. And here also the same case, e power x plus 1 whole power minus 3 and e power x dx. Now in the next step we have to apply integration on either side of the equality. We'll get integration to e to the power y plus 1 whole power minus 2 dot e power y dy is equal to integration to minus e power x plus 1 whole power minus 3 e power x dx. Now I will solve either side of the equality by substitution method. Let t as a variable is equal to e power y plus 1, and the derivative of t with respect to y variable is e power y. Now you have to shift the dy to the right side and we'll get e power y dy. Let's call this equation equation number 1, let's call this equation equation number 2, and let's call this term, the left side term, as term A. Let's call this term as term B, and we'll also suppose here that let w is another variable that is equal to e to the power x plus 1, and the derivative of w with respect to x variable is e power x, and dw is equal to e power x dot dx. Let's call this equation 3 and let's call this equation 4. Now we have to replace equation 1 and 2 in term A, and we have to replace equation 3 and 4 in term B. So we will get here integration as we have supposed e power y plus 1 is equal to t. So you will put here t power minus 2, and we will replace e power y dy this term. This term we will replace by equation 2 that is equal to dt. So you will get here dt, and on the right side we will replace ex plus 1 whole power minus cube, only the internal term ex plus 1 by equation 3 which we have supposed that w is equal to ax plus 1. So we'll put here just w or minus cube, and we'll replace ax dx by equation 4 as we get here dw is equal to e power x dot dx. We'll replace this term by, now we can apply integration to either sides of the equality. So on the left side, the integration of t to the power minus 2 is just simple. We'll increase the power of t by 1 and divided by that power. So we will get here t to the power minus 1 divided by minus 1, and on the right side we will get here minus w all to the power minus 2 divided by minus 2 and plus c. C is the constant of integration. Now we have to replace again t and w as we have supposed above. So from equation 1 and 2 we can replace t and w. The t is equal to e power y plus 1, so we'll write here e power y plus 1 whole power minus 1 divided by minus 1. On the right side we will get that minus plus, so we will get here e power x plus 1 whole power minus 2 divided by 2 and plus c. Now this is the general solution of the given differential equation, but first we have to rearrange this equation. So we will get here minus 2 e power y plus 1 whole power minus 1 is equal to e power x plus 1 whole power minus 2 and plus c. And we have to shift this term also to the left side, and we will get here minus 2 e power y plus 1 whole power minus 1 minus e power x plus 1 whole power minus 2 is equal to c. Now we have to multiply both sides by minus, so we will get here 2 power y plus 1 whole power minus 1 and plus e power x plus 1 whole power minus 2. On the right side we will get here again minus c. So let minus c is equal to c1. It will also give another constant. So you will simply put e power y plus 1 minus 1 plus x plus 1 whole power minus 2, and we will just put here c1. Now this is the constant of integration, which is c1, and this is a required general solution of the given differential equation. Thank you.